Hola, ¿qué tal? ¿Todo bien? That's all I know of Spanish.
No, you know more.
I know a bit more, yeah, but... Yeah, no, I know bad words that Esteban taught me, that's it. So I would like to start by thanking the FAST organization. They made it possible for me to be here today. I'm really glad. I love the city, the country, Buenos Aires, and it's really cool to be with you today. So thank you, the FAST organization. So my name is Nicolas Petton, and I'm here today to give you a presentation of Ember and a demo that I hope will be okay, will run fine. Yes? You need to do an announcement now? Microphone. Okay, so I keep going. Some words about me. I work at INRIA in France, in the team led by Stéphane Ducasse, that is over here not paying attention. Yeah, he's forced to smile now. I'm an engineer there, and I work on JavaScript, security, and a bit of Ember there. And I also have a second hat, kind of. I'm the co-CEO of a French company named Object Fusion, where we do web applications in Smalltalk, custom web applications for customers. Okay, so that's about me. So Ember, who already knows about Ember? Can you raise your hand? Okay, oh good, not bad. Okay, so I have here a few slides of introduction for those who don't know about it and those who know more or less what it is. So Ember is, first of all, it's a small talk. So when I say it's a small talk, I mean it's a small talk, a real one, like you would expect from any small talk, right? So it has all the core libraries that you might expect from a small talk. It has collections, streaming libraries, classes, meta-classes, everything is reified like any small talk. But it's not only a small talk, it's a small talk that runs on the web, so it has on top of that web libraries. If you know Seaside, or if you tried Seaside, you probably know its HTML canvas and its components. So Ember has something very similar. It has an HTML canvas, just like Seaside. So if you fire up Ember and try Ember, you will want to draw something on your page. You can use a canvas. It's almost the same API. It's very similar. One difference is that in Seaside, actually, when you use the canvas, you write into a stream, and you send this stream over the wire to the client. It's the HTML page itself. In Ember, it's a bit different because each tag of the canvas actually hold onto a DOM element. So we have first-class DOM element in Ember canvas. So that's the difference with Seaside API. And finally, Ember has a development environment, which Smalltalk doesn't have one. So we have one in Ember, and of course it runs in the client. But it's an environment like any Smalltalk environment with a transcript, a workspace, class browsers, senders, implementers, class references, and so on and so on. And a work-in-progress debugger that I will demo a bit later. Okay, important thing for us, Ember is fully open source. It's released under MIT. Which means you can take it, use it, play with it, fork it, as long as you respect the license. Ember compiles to JavaScript. It compiles to JavaScript incrementally, and it has several meanings. The first one is that you don't have to install anything to have Ember running in a page. It's just a bunch of JavaScript files at the end. Another meaning is that Ember can interact with JavaScript. It wouldn't have any sense to have a Smalltalk that runs in the browser and cannot communicate with JavaScript. It would make it completely useless. The JavaScript ecosystem is quite large. You can find thousands and thousands and thousands of libraries out there. With Ember, you don't have to write any glue code to use all of that. You just use it from Ember. Another feature of Ember when it comes to JavaScript is the ability to inline JavaScript directly in your Smalltalk code. So in Ember you can choose for a method to inline JavaScript instead of writing Smalltalk code. So that allows us to avoid having primitives, for example. We just inline JavaScript. For those of you who used Ember in the past, it was completely free to inline JavaScript wherever you want. Now you have to choose between a Smalltalk body and a JavaScript body for some technical reasons. Finally, for this introduction, one very cool feature for us is that Ember is written in Ember. At the beginning, the first version of Ember was written in JavaScript. So the compiler was written in JavaScript, the parser was written in JavaScript, the Aliased was written in JavaScript, everything was written in JavaScript. And then once we had a stable and featureful enough version of Ember, we decided to rewrite everything in Ember and throw away all the JavaScript code. So nowadays, Ember's compiler is written in Ember, the Aliased is fully reified, the contexts are reified, classes, beta classes, everything. Compile methods are also reified. So Ember is written in Ember, and that's because Ember is so small, it's a small kernel, the base kernel is less than 200 kilobytes, it makes it very nice to play with and experiment. It's so small and completely written in itself. It's really easy to just play with it, try something new in the compiler, break it, reload the page, try something else. It's very cool. Okay, so that was the introduction. I would like to tell you a bit about what happened last year or last years in Ember. Ember is more or less 3 years old, I think. It started under a different name. It was named JTalk, and we decided to rename it because the name was awful. So now it's named Ember, and since the last year a lot of things changed, and I'm really glad that it changed so fast and evolved so well. So first of all, we have a brand new IDE. It's still released as an alpha, so you can try to have the old one for the daily use. But if you want to try the new IDE, it's named Helios, you can. And in fact, it's so much better than the old IDE that we Ember developers use it all the time. We don't use the old IDE anymore. The old IDE is just in maintenance mode until Helios is fully finished. So we have this new IDE that I will show you in a few minutes. And since last year, we moved Ember from my own personal GitHub account to a new organization. And that was because it was not only my toy anymore, it was not only my project, but it was a core team's project. So now you can still find a fork of Ember under my account, but the main Ember has its own organization on GitHub and core team there. So that's really nice to see one of your babies being adopted and used by others and developed by others. And I'm really proud of that. That's the core team today. So most of you know Joran, probably. He's been around in the Squid community for years, and he jumped in Ember very early. 2 years ago, or 3 years ago, he gave a presentation with me at ISAG. And Joran decided to jump to Ember not only because it was a small talk, but because it compiled to JavaScript, and that allowed him to play with it. Because nowadays everything runs JavaScript. He had a phone with a JavaScript HTML5 operating system on it, and he could write applications in Ember and debug live on his phone. He found that so cool that he decided to jump in and hack it with me. A bit later, Manfred and Herbert joined. Manfred is doing a lot of things on the command line. Previously, Ember didn't have much support for the command line, and Manfred found it somehow lacking. So he decided to improve that and write a command line compiler, a proper REPL, a server that is written in Ember and runs from the command line. And he's also helping a lot in the community and doing a lot of things. Herbert, on the other hand, is working on the hardcore compiler stuff, optimizing speed, using less memory, faster bootstrapping, stuff like that. And we have a new core member, Matthias Springer. He was Google Summer of Code this summer. He was working on the port of Athens for Ember. And he did such a great job at it and learned so many things of Ember that he just naturally joined the team, and he's the new baby boy of the Ember team. So that's the new team. We have more people contributing to Ember. We have around 30 people contributing to the core of Ember. A bit more if you take the examples repository, but around that. And we have 107 forks on GitHub. People, not all of them are active, of course, but a lot of them are, and they are just playing, forking it, and doing stuff for it, sending us pull requests, and it's really nice. I think that makes Ember the most forked Smalltalk project on GitHub. That's cool. We have almost 500 followers on GitHub. Again, I think that makes Ember the most followed Smalltalk project on GitHub. That's pretty cool. And we have 2,500 commits since the beginning. Ember is very active. I'm showing you this number to show you that Ember is very active, and it's more and more and more active. It's really a lot of effort from the entire team and all the contributors, and it's evolving very quickly. By the way, we have not released the 1.0 release yet, so we are evolving so quickly that we cannot not always maintain backward compatibility. So be aware. Okay, so I would need someone here, thank you, to hold the microphone when I give you a short demo. Thank you. Muchas gracias. Yeah, I think is it okay? Can you hear me? Yeah, good. Okay, so that's the increased font size version of the old IDE. So it's in a page, as you can see. And here on the left, we have the transcript that you all know, the workspace that you all know, SUnit. So we can run the test right now, see if everything is okay. Yeah, looks fine. No. Okay. And here is a class browser. It's a class browser, like, nothing new here on the left of the packages, and the classes, the method protocols, and the methods on the right. So nothing new here. What I can show you, however, is the web API. So the counter class is, do you know the counter example in Seaside? It's the same, but for Ember. It's a nice, easy introduction for Seaside users. So you see here that the counter is a subclass of a widget, which is like a component in Seaside, and it has a count instance variable initialized to 0, and a header. You will see what the header is. So let's take a look at it. Initialize, nothing interesting here. What we might want to see, however, is the render. So render on. You see Seaside uses render content on, I think. Here it's render on. Render on 2. Okay, so it's the same. Oh, it's not nicely formatted. Let me fix that. Okay. So you see that it's really, really close to Seaside. We create an H1 tag with the value of the count. And then we have two buttons, one to increase and one to decrease the counter. The callback is on the click event, and it takes a block as an argument that we call self-increase and self-decrease. One difference, though, is that the H1 tag is kept in an instance variable. Why? Because it's a live DOM element. So instead of refreshing the entire counter, we can only refresh this element. And that's, if you look at the actions here, that's exactly what we do. We increase the count value and we refresh the content of the header. Okay, so let's play with that. Continue. That should answer a counter. Append to jQuery. Body as jQuery. Okay, let's do that. Okay, so we should have a counter here. Very nice. And I can increase and decrease. Okay, so that was for the web API. Now I would like to show you a bit more about the JavaScript interaction from Ember. So in Ember, I can call any JavaScript object, the global object in the browser being the window object. So if I print that, there is no glue code here. It's not defined in Ember. It's just an object that lives in the JavaScript environment, and since it's the same runtime, Ember has access to it. So I get an object. We can see that it's a JavaScript object because it has these square brackets around it, and it's treated as a JavaScript object. So nothing really fancy here, but if I now inspect, cannot inspect. Okay, so to do that, I will open Helios, and I will show you Helios at the same moment. Okay, so this is Helios. We'll show you more about it later. For now, I just want to inspect the window object. Inspect it. Okay, here I have the window object. So I can inspect it as any smalltalk object. You see a lot of things in the window object, but basically it's an object. We can have access to it. Accessing to JavaScript objects is done through a proxy, and we have access to anything that's defined there. So if we want to see the document object, you see it's an HTML document. If you want to see what is require, requires a block closure. What is a block closure in JavaScript? It's a function. It's the same object, because Ember maps one-to-one with the JavaScript equivalent whenever it can. So if you could write a block closure in Ember, it is actually a function in JavaScript. There is no difference. Kind of look at all the things like jQuery. What is jQuery in Ember? It's another block closure, right? Okay, now that I'm here in Helios, let me show you a bit about it. So why we needed to write a new IDE is basically because the first one was written in like a week. And at the beginning it was okay, but then more people started to use it, asked for more features, and the design of the first IDE was not that good. So we decided to restart it from scratch. And one nice thing about Helios is that it's remote. Here, this is a different window from this one in the back. But I'm still browsing and interacting with the page here behind. So if you can give Helios an environment that is compatible with it, that answers classes, packages, that can compile and everything, this environment object can be used by Helios to browse it. Helios doesn't browse local environments. So it means that, for example, if you want to browse Faro from the web, let's say, all you have to write is this glue environment to make it work with it. So here we are browsing the page behind, and I can try to find, have you seen the bar on the bottom? So Helios is heavily based on keyboard shortcuts. If you want to click everywhere, you can do everything by clicking. If you don't, it's my case, I want to never leave the keyboard. So there is, by default, it's Control Space, and I open the main keyboard helper on the bottom, and here I can just type what's written. So I want to open O, a browser, B. Now I want to open a workspace, I want to switch, I can switch like that. I can close this workspace, and here I'm back to my browser. Then I can navigate from the keyboard everywhere. I can, if I want, find a class. In my case, I want to find a counter here. And I want to go to the increase function and increase by, let's say, 5. I can save it, Command S on the Mac, go back here, increase, it increases as I want. View here. Okay, so that's one of the nice features of Helios. I can also do a number of things, like if I want to, it's not speaking here, move the method to a new protocol that I name hello. It's done. So you don't have to leave the keyboard, and that's really nice. One other thing that is new in Helios is a preview work-in-progress debugger that will show you a bit later how it works. Okay, thank you. I will go back to my presentation. I will have another demo later. Thank you. Okay, so that was Helios and the web API. Getting Ember. So now that you are all excited and want Ember, here how to get it. So the safest way to get Ember nowadays is to use the Node package manager. Do you know what is Node? Yes. For those who don't, Node is an embedded V8 that runs on the server side or on the command line, not in the browser. So you have a JavaScript virtual machine that you can run anywhere. And it has on top of that some libraries. So we use that, and it has a package manager with like 30,000 packages there. Pretty much anything you want is there, and you can use it from Ember for free. And one of the packages on Node is Ember itself. So you can go to node.js.org. Here you have the link on the bottom if you can see it. Node.js.org and download Node. It comes with NPM, the Node package manager, and once it's installed, you can just npm install Ember, and you will get Ember installed on your machine. So that's the easiest. Of course, with that you would get the latest table, and you won't get the bleeding edge. For that, you need to clone Ember. So to clone Ember, you do a git clone from the project in GitHub. Nothing new here. And then you go to the project, and you have a couple of dependencies to install. For example, for the browser, you will need jQuery and other libraries for text editing and everything. And for the command line tools, you will need lib-readline and stuff like that. So you have two commands. If you're only interested in the client side, you do power install. And if you're interested also in the command line, you do npm install too. And that will bring everything for you. You won't have to do anything else. It's written, it's risky, the subtitle here. That's because most of the people in the community just use the latest. We break it, it's the latest, it's master, right? So we try not to, we have continuous integration, but it breaks from time to time. And it has currently in master one bug, for example, that prevents us from erasing it. Doesn't mean that you cannot use it, but be careful. Okay, so to start Ember, once you have everything installed, I have a terminal here. Can you see? Yes, good. So you can do bin Ember serve. And if you don't give any other parameter, it will just start it. Oh, it's already started here. Yeah, it started here. It will start it on localhost port 4000. You can choose another port if you want, or do fancy stuff. And what it is, it's simply a WebDAV written in Ember that will serve the files. So if you don't want to use that and want to use Apache as a WebDAV, instead, fine, it works. But here it's a lot simpler and more convenient. Where are you?
Is it running on Node.js?
Yeah. It's Ember code compiled to JavaScript and running with Node. You also have a REPL if you want to use a REPL. So it's the same, bin Ember, and you just start the REPL instead. REPL. Again, it's what? It's this one. Okay, so here I have a REPL. I can show you that it really works. Okay, I can do object new, whatever. Yeah, so you have a REPL. If you want to use that, it works fine. It's using lib-readline, so everything that works in readline that you know works here too. And it's just, you can browse it if you want. In Ember, it's 50 lines of code because nodes provide everything we need to have a REPL. It's just wrapping around the compiler to have it running here and printing this back to the console. That's it. Yeah. Where are you? Here. Okay, so last warning about master. You can use from master, but don't deploy from master. People tend to do that, and they send that on the mailing list. I don't understand, this is broken. Then I ask, okay, can you show me the version of Ember that you're using? It's git commit blah. I say, what? No, don't do that. Don't deploy from master. This is silly. It's broken half of the time. If you want to deploy from the master version instead. So, warning, don't deploy from master, please. Okay, so we have in Ember a completely new compiler toolchain that is, the design is taken from Opal, written by Marcus for the most part for Cairo. So it has, if you looked at Opal, it has more or less the same design than Opal. And what is really interesting with this new compiler is that it allows us to do way better inlinings because it's so much better than the old compiler, and we have a lot more knowledge about what we do, and we can do much better inlinings. Another thing is that this compiler doesn't compile doing manual lookup. So previously, the old compiler, which was one big visitor knowing everything with a lot of state, it was very complex. This one, it compiles, if you write self hello, it will compile self.hello. So there is no lookup anymore. And we entirely rely on the JavaScript to do the lookup for us, which is way faster. There is no cost anymore there. It was a big complaint before that Ember was slower than JavaScript because of that. Also, for inheritance, we now rely entirely on the prototype chain of JavaScript with a few exceptions. Which means that at runtime it doesn't change anything, but the bootstrap, because each time you load Ember in a page, it bootstraps itself. It's from source code. So each time you load Ember, the bootstrap is much faster because we only create prototypes that are seen as classes on the Smalltalk side. So it's a lot faster and it uses a lot less memory. Again, before, since we did the inheritance by hand, every compile method was copied over to the classes. Now we rely on the prototype chain. So it's a much better compiler with a new, much better architecture. So you can see here an overview, simplified slightly. So we take the AST created by the parser, and the first step is to have a semantic analysis. Previously there was no semantic analysis. So it meant that in some cases you could even compile Smalltalk code that was not semantically valid. Nowadays, no way. So we annotate the AST nodes with this visitor for later use. So we give it some knowledge about the scope, what kind of variables it is it referenced somewhere, things like that. And then the second step is to flatten the AST and create a new tree that is almost a list. And we do that because Smalltalk has some semantics that make it difficult to optimize, at least in JavaScript, like cascades are not that cool for us, and some other things. So we flatten all that, and we get an intermediate representation tree, which is almost a flat list. And that is a lot easier to inline. Now we have a simple list of nodes with the semantic knowledge of everything. So the fourth step, which is optional, but by default it's on, is to inline nodes, like if true, some blocks, some non-local returns are inlined. So it means that if you use the common messages, you won't have context, it will be inlined, and local return will be inlined. So it's way faster than before. And then the final step is the JavaScript output, which is again a separate step. The reason is you might want to output using a different stream that doesn't give you any debugging information for the deployment. So that's the new architecture. About the better inlinings, I want to show you a couple of slides. I don't have much, and it's the only technical slides I have. It's not that technical, but anyway. So on the top, you see the Smalltalk code, and on the bottom, you see the JavaScript code that is produced by the compiler. So here on the top, you have a method, very simple, true if true, return self. The problem with that is, first it creates a context, so there is a closure that is created, and then there is a non-local return. And JavaScript doesn't have non-local returns. So it means that in JavaScript, you create an exception and catch it. And that's slow. It's not terribly slow, but it's slower than what you could do. So the compiler here is inlining the if true send into an if statement. That's already better. And because there is no context anymore, it becomes a local return. The second one is just a tiny bit trickier. You see here that we assign the result of the message sent to a variable named A. The naive way to do it would be to write A equals if blah blah blah. The problem is if is a statement and you cannot assign to a statement in JavaScript. So we have to trick it and move some nodes away in both branches of the if statement to make sure A is always assigned. So that's how it is compiled now. Finally, some remarks about this new compiler. First, I already told you the non-local returns are slow. They're not terribly slow, so you can use it, we use it, The thing is, if you need high speed, you might want to avoid it. Most of the time it will be inline anyway, so you don't have to care. But sometimes it's not, and if it's the point where you need speed, you might want to avoid it. And finally, the JavaScript proxies that I showed you with the window object, it's very handy. We use it all the time. Again, because it's a proxy, it's slower than inlining directly JavaScript. To give you an example, Matthias, when he was doing the Google Summer of Code with Athens, was getting 2 frames per second. Not that good. Then we discussed it, and he showed me how he was doing it, and he was using proxies all the time for the canvas, the HTML5 canvas, and it was slow because of that. Then we rewrote just 5 or 6 methods to, instead of that, inline JavaScript, and all of a sudden he got 40 frames per second without doing any optimization. So the proxies are very nice, but if you need high speed, don't use them. Finally, some words about the new Aliased interpreter. So now that we have a proper semantic analysis, it's quite easy to interpret the Aliased nodes directly with a new visitor, and we do that. The new Aliased interpreter is quite mature now. It's able to interpret everything in the Ember syntax and semantics. When I mean everything, it means that we run all the tests of Ember, but instead of compiling them, we run the Aliased interpreter and check if everything is green, and everything is green. So it's pretty good, and it also includes an experimental debugger. I say experimental because the UI of the debugger is really new, but I can show you some stepping there and there. And of course, this Aliased interpreter is much slower than the compiled code. I think 10,000 times slower. But we don't care, because we use it for debugging, right? And when you debug, you don't need that much speed. Okay, so let me show you the debug. Yes, please. There. Okay, I think I had Helios there, yeah. So I will stay in the counter here, and in the increase method, I will introduce a bug. I will say +1. Bug, like, I don't know. What do you want? A halt is enough? Mm-hmm. Okay, halt. Okay, so now let's go back to the counter. So we have 14, try to increase, nothing happens. If you go back to Helios here, you get nothing. Amazing. Love it. Okay, let me restart. Demos never work. I hate that. Okay, let me reload Helios. Don't look too much at what I'm writing here. I will explain it in a minute. So. Okay. So open workspace, counter new, open to jQuery, body as jQuery. Printed, yeah. So was it added? Yes, I have my counter. So let's open a browser, counter, increase, halt. Okay. So I told you it was experimental, right? If it doesn't work, don't blame me. I have my debugger. Awesome. Yeah. So it is a debugger with the stack that you all know, and you see that do you see the highlighting here? The signal is highlighted. Okay. So you see that it knows which message was sent and where we are, and here, oh, it was the halt. Okay. So if I step over here, the new debugger is so smart that it will evaluate halt again. So it will open a new debugger, but that's okay. I just want to step over. Okay, so now I'm in the plus. So if you look at the count, that's 0. If I step over, it's 1. And if I can, show you here, look on the left, once more, and we got 1, plus some debuggers. Okay, so that's the new debugger. So as you see, the UI is pretty new and immature, but it shows that we can interpret Ember. It's okay, I'm done here. We can interpret everything and step over. It's very important for us to have that. Previously, we were only showing the stack, and we couldn't do anything with it. But what Smalltalk could that be? When Smalltalk is known for its debugger, people are amazed when they see Smalltalkers spending their life in their debugger and even writing code in their debugger. That's how we do, right? And in Ember, we couldn't do that, so we are filling that gap. And I think now it makes it Ember the only small language compiling to JavaScript, having its own interpreter and having its own debugger. There is no other language, even, I don't know, CoffeeScript, that's the most known, probably doesn't do that. So that's pretty cool, I think. Okay, so I will go quickly over that, mainly because it's the most incompatible change that we made since the last release, and because the new release, 0.12, is coming in the next few days, maybe even today, I don't know. I want to show you that so that you don't get scared when you try the new Ember, right? So we rewrote completely how we handle packages in Ember. Previously, a package was compiled to a single JavaScript file, and this file was loaded by the browser. It meant that if you had 10 packages or 20 packages, they were written one by one in the DOM and loaded just like that. So it has several issues, like loading it and depending on the browser, loading it correctly. Another problem is writing external packages. So we saw after some time that people to use Ember as a library were simply cloning it and adding packages as if it was Ember packages. But it was not, it was their packages. Ember was supposed to be used as a library. But it was really hard to do that because we didn't have proper commit path for packages. They were all saved at the same place. So it was a big issue. And then the last issue was handling dependencies. Since it was a simple JavaScript file, there was no way to say, okay, to have the compiler, I need the parser, and to have the parser, I need the base kernel. No way. So we decided to rewrite everything, and the solution we used two solutions. The first one is to completely decouple the packages from their transport. Transport, we mean how we load and how we save them. And the second one is to write every single package as an AMD package. You know what is AMD in the JavaScript world? You don't? AMD means asynchronous module definition. So because JavaScript is asynchronous, an AMD is a package definition that will evaluate a callback and load everything only when its dependencies are loaded. So every package in Ember now can specify its dependencies and be loaded at the proper moment. And to use that, we use require.js, which is installed when you do npm install or bower install, so you don't have to think about it. But anyway, behind the scenes, it's using it. And it makes it a lot more flexible. So alongside with the class definitions that you know, we have a new package definition. So in Helios now, if you open it and click on a package, you will see this. So this is the it's a real package definition for the compiler. So you see it's a package named compile core, and its transport is an AMD transport, which is the default. If you don't want to use AMD, you can use something else. You have just plain old JavaScript transport, but it's not used anymore, but if you want, you can use it. And we specify a namespace. The namespace, it's not a namespace in Ember. Ember doesn't have namespaces. It's a namespace for the AMD module. So each module is saved into a namespace. And by default, the namespace is just the path to save or load it, right? In this case, Ember core is just an alias to the base directory of Ember. But if you create a new one, it will save it where you say. So it's like more or less the directory on your disk. You can see it that way. Now that we have AMD modules, we have two distributions of Ember. The first one, Ember/devel, is the all Ember with the compiler, debugging tools, environment, and everything. And if you want to deploy, we have a second one, Ember/deploy, that doesn't include anything except the base kernel and the web libraries to do web development. And this is an 200K, I think. It's very small. This is how you load it now. So you see that we have two scripts. The first one is to load ember.js that defines the modules. The second one is require, that is shipped with Ember. And then you decide what to load here. So in this one, we say we require Ember devel. That's the page I just showed you. And when that's done, that's the callback of the package. We can evaluate a function with the smalltalk object, and in our case, we just want to initialize it. If you're lost with that, don't worry. The main index.html page has that already. You can just tweak it and load your own packages here, and that's it. But if you want to play with it, you can. Okay, so enough with the packages. I want to show you Athens. Who knows what is Athens? Oh, okay, so let me explain. Athens is a work of Igor in our team. He made a vector graphics engine for Pharo that works with, it's independent of the backend, but now it's Cairo, I think. And it's really, really nice because all of a sudden we go from a pixel-based rendering to a vector-based rendering. It's really cool. And Matthias, this summer, did the Google Summer of God to have a different backend that would use the HTML5 canvas for Ember. I think I have it here, yeah. So unfortunately the page is too small. So here on the top you have the surface where we will draw, and on the bottom you have the code. No, it should be side by side, but the resolution is not good enough. So let's start. Let's just do it. So here it just creates the surface that is here to be able to draw on it. If you wonder if that is compatible with the Pharo version, yes, it's exactly the same API, it's the same code, just the backend is different. Let's do a few steps. So what does it do? Yeah, just draw a rectangle. Nothing very fancy. So I will just do it some steps. Okay, black surface. It has a lot of things like rotating, scaling, all the stuff that you might imagine. Okay, but what is quite better to show you is, boom, okay, stroke paints, gradients, stuff, paint modes, clipping, drawing text. This is cool. So we can draw text with vector graphics, cool. And we can, you know the famous, isn't that what? No, come on. No luck today, huh? Do it. Yes, all right. So that's the famous tiger SVG drawing, and it's animated. In Safari here with this version we don't have that many frames per second. In Chrome we are close to 60, but also maybe this is not up to date, I just took it from the internet. It was a demo that Matthias gave me. So that's the tiger, nice. And of course once you have a graphics engine like that, you want to do more with it, right? So that's the next step that he did. And guess what this is? Morphic surface. Oh. Of course, it's not the same morphic as Pharo because this is vector-based. So it means that this is morphic, but rendered with vector graphics. Let's step over. Okay, another morph. These morphs are a bit boring, right? This is already better. So here is a morphic window, you see? I can close it, can resize it, and I have some widgets here, radio buttons, can increase, I have the callbacks working. Pretty nice. I can show you another one maybe. Do it. This is another morphic window, and what you can see, which is very nice, is that you can rotate and scale. It's vectors. So I think Ember has the first version of morphic being vector-based, right? Okay, so that's for Helios. Some propaganda now. If you want to contribute to Ember, you're welcome, more than welcome. It's really easy. You just go on GitHub. It's github.com/ember-smalltalk, or you just look for Ember there. You will find it immediately. The idea to contribute to Ember is just to clone it, do some changes, send us a pull request, and then check on Travis if the build, because we have continuous integration, the build passes. If it doesn't, we cannot integrate it. And then on the pull request, we can talk about it, and then if it's good, we merge it, and that's it. You're a contributor to Ember. Congratulations. A lot of activity of Ember, the development itself, doesn't happen on the mailing list, but on GitHub. So you are also welcome to just send a bug report if you find an issue, or just ask for a feature there. You just create an issue, feature request, you ask what you want, and we talk about it. A lot of development happens there. Some words about the community. A lot of people tend to fork Ember and play with it, so a lot of discussions also happen on GitHub. So not everything happens on the mailing list. But still a lot happens on the mailing list. The mailing list is a Google group for the best and the worst. It's ember-lang on Google Groups. And we are also most of the time on IRC, so you can always find some Ember hacker there, ember-lang on Freenode. Okay, so that's my last slide with the homepage of Ember, ember-lang.net. You can go there and it's loaded in the page if you want to play with it. Or there are instructions to download it, the same as I showed you earlier. So thank you very much. And I think I have... I do have some minutes for question. Yes? So is there any question? Yeah?
Yeah. How do you handle exceptions and JavaScript integration, especially resumable exceptions?
With?
Resumable exceptions. The JavaScript integration.
I don't hear you.
Resumable exceptions.
Resumable. Okay. So in Ember, so there are two kinds of exceptions. The ones that happen in the Smalltalk stack, and this one are easy to catch, and the ones that happen outside of the Smalltalk stack and that we don't catch. So it means that if you have a JavaScript bug that is not related to Ember, we won't catch it. Now, if you have a bug that is in the Smalltalk stack, we will catch it even if it's not a Smalltalk bug. If it's not a Smalltalk bug and it happens in the Smalltalk stack, like your code library, something goes wrong, it will pop up a debugger saying there is a JavaScript exception. Okay? But resumable exception, Ember does not have resumable exceptions. Right? But what we have, so it does not understand. Okay. Yeah.
Can you save an image or something similar?
No, you save package. The Ember doesn't have images. Each time you load it, it bootstraps from source code.
Okay.
There is no image. But it behaves more or less like an image.
Okay.
The runtime, but that's it.
Okay.
Yeah. Yeah.
I mean, I'm having a little bit of trouble understanding the type of application that I would write with Ember.
Mm-hmm.
Because it's very different from the web development type of application idea, I think. Because my understanding is that if you want to write an application with Ember, it will be more like a desktop application than a web application. Is that right? Because it doesn't make sense to load Ember on each page.
No, the thing is, maybe some of you are using Smalltalk Hub. Smalltalk Hub, the server side is written in Pharo with a Mongo database, and the client side is entirely written in Ember. So we don't load Ember for each page. It's the same page.
Okay.
We never reload the page. And it's more and more common in web applications to do that. I think Twitter does that, Gmail does that, maybe Facebook, I don't remember, probably does that. So it's what is called, it's a hype word, it's called one-page applications.
Okay.
It means that the UI is in the client and the server logic is on the server side. And to communicate, at least in our case, we communicate through C-side REST and JSON. the nature of Ember, with its nature, it's obvious that it can read and parse JSON, and with C side it's very easy too. We just communicate with JSON. Yes?
I was going to ask if there is hierarchy to the communication package.
They here wrote a package named Kaliningrad for C side, and what it does is it serves Ember. So you can have Ember without installing anything. You just have the file image serving Ember, and it also saves the packages as Monticello packages when you save. And for communication between the both for your application itself, what I use nowadays is just C-side REST, plain C-side REST, or even Zinc REST. Okay, there is something in progress, but cannot talk about it now. But there is no final solution to do it. Okay, yet. Yes.
I'm sorry.
Yeah.
When you see the smalltalk code comes with the complete JavaScript code. Is that right?
Not exactly. Yeah. So each time you save a package, I can show you here. Yeah, let's say I want to change my super great improvement to the counter example. So I can do here K for commit, or I can go to the menus. I will just press K. It commits the package. So it commits it to disk with the new AMD stuff that I showed. So it's just to disk with the rest of the Ember files. And it saves two files. The first one is the .st file. That is the only one you really need, right? That you can recompile later. And the second one is the JavaScript file. That's just for convenience. And for the core, we need, since Ember is written in Ember, we need a compiled version of it to compile it. But for you, for external packages, yeah, it saves the JavaScript file, so you don't have to compile it by hand the next time. That's it.
Okay.
Yes?
Did you mention anything about documentation? What do you have? Something to read, documentation?
Yeah, sure. I forgot to show that. So Helios has a nice documentation system. So you see here, there is a doc button. So if I click on it, or there is a shortcut for that, it will on the right show you the documentation for this class. Okay. So here you have, the documentation, and it's because we write things like in an email, it's more or less Markdown. So we format it in Markdown now, and it's working pretty fine. And because it's the web, you can also click on things. Like for example, here it says that it's a subclass of widget. So I can go here, what is a widget? It's a class of interfacing object, you have the API, blah, blah, blah. You can go up, and no, not up, okay. It's a subclass of nil, I cannot click on nil. Okay. But anyway, so that's for the documentation of classes. Almost everything is documented now. We only have a couple of classes that miss a documentation. So everything is documented. We can go, you see undocumented classes, they have a mark on the left here, and you see that everything is documented. And also we have two more things. If I have internet, not sure. I don't. If you go on the website, there is a documentation link with the latest documentation, which is built both from the class comments plus some chapters. Okay, so you can go there. And also there is a wiki on GitHub. Oh, great. There is a wiki on GitHub with maybe 20 pages. How to get started, how to compile from the command line, how to write packages, stuff like that. So here you see you have the prof Steph tutorial here, and here you have the documentation. Okay, that is a bit slow, but okay. And if you go on GitHub, you will have the wiki. Yes?
Sorry, I have another question. Do we have some structured benchmark test so we can see certain changes, improve those?
Yeah, we thought about that. We will have one. For now, we don't. And the reason is writing proper benchmarks. It's not that easy. So, right? It's not that easy. So we have the typical bench fib and stuff like that. But We don't feel like it's good enough. So we don't have automatic builds with the report of the speed. But I can tell you a bit about speed if you want. Ember, when it's compiled without the debugging informations, now is pretty fast. It's about the same speed as JavaScript. It's a tiny bit slower, but maybe you lose 10 or 15%, not much more. With the debugging information, you have half of the speed of JavaScript, but you don't deploy that, right? It's still pretty fast. Okay. No more questions? Yes?
I have a remark.
Yes.
Thanks. Because when I see the numbers, I'm mad. So at least I was wondering why I didn't do that before. Because this is JavaScript, but this is not code. I don't just JavaScript.
Yeah. Okay, thank you. You're welcome. Thanks.